Welcome to the PECO Virtual School. I'm TWINO LAMBERT, going to take you through the topic of set theory, which is part of our paper 2. So to begin with, there are key concepts that we need to know as far as set theory is concerned. The definition of a set. In our primary school, we defined the set as a collection of well-defined objects. You can think of a set in any form: a set of girls, a set of boys, a set of exercise books, a set of subjects, and so on. On the other hand, an empty set is a set with no elements. A subset is a set that is part of a larger set. Think of any subset. I can say that senior 3 is a subset of a school. A universal set is a set of all other elements under consideration. For instance, when you look at a school can be looked at as a universal set. A Venn diagram is a set diagram that shows the relationship between different sets. For any sets A and B, 1. Number in the universal set, represented by that, the symbol for the universal. So the number in the universal set, this is the symbol for the universal, is read as the number of members in the universal set. This means number of members in all regions of the Venn diagram. Number of A represented by this is read as the number of elements in set A. Number of A complement means the number of members in the universal set that are not in set A. A complement, this is now the symbol for complement. You can either use this or you can use this. This means A complement. So A complement means the number of members of the universal set that are not in set A. Then the union of two sets, A union B. This means members of either set A or set B. The entire region covering the two sets. A intersection B means elements, or this is the region that is common to the two sets A and B. A intersection B complement, this with a complement on B. A intersection B complement. Now realize that the complement is only on B. So A intersection B complement, this means the elements that belong to set A only, or elements that are in set A but not set B. Elements in set A but not in set B. That's what this point means, this particular part. A intersection B complement. Elements that are in set A but not in set B, which we call as set A only. Now this, when you compare these two, this one and that, now this one is A complement. You realize that the complement is now on A intersection B. Now this one is read as A complement intersection B, and this means elements that are not in set A but in set B, or elements that are in set B only. So A complement intersection B complement this. A complement intersection B complement means neither set A nor set B. Neither set A nor set B. So A complement, this part here, A complement intersection B complement, outside A, outside B. Elements that are not in A at the same time not in B. So A complement intersection B complement is the same as A union B in brackets complement. So the elements that are not in A at the same time not in B are the same as the elements that are outside the union but within the universal set. Now this A union B complement, this means members of the universal set that are not in set B only. Now A complement union B, this means members of the universal set that are not in set A only. That are not in set A only. Now A complement union B complement, this means members of the universal set that are not in the intersection. Now all these terms we shall be looking at them more in detail as far as the Venn diagram is concerned. We can now consider the Venn diagram illustrating the regions relating to two sets A and B as follows. So we can sketch that. It is a Venn diagram. Now this rectangle here represents the universal set. Now this is the symbol for universal. So this part, this rectangular part, the whole of this part is the universal set. So this is the number of A. Now this is A. The whole of this is A. This is set A. The whole circle, the way I'm demonstrating here, this is set A. Now this is set B. This is set B. So this is our set B. Now this region that overlaps in the two sets, now this is the A intersection B. A intersection B, this part, it has elements that are in set A at the same time are in set B. Now this part, only this one here, this part here, is what we call set A only, elements that are in A but not in B. In A but not in B, it is only this part here. We must appreciate the difference between set A and set A only. Once I say set A, I'm referring to the whole of this. Now this is A. The whole of this is A. This is set A. The whole of this is set A. Now if I say A only, I will refer to this part. Elements that are in A but not in B. Now this part is what we call B only. Elements that belong to set B but not set A. This is the B only, which means this part. Now like I mentioned earlier, once you talk about set B, now the whole of this is set B. You can see the whole of this part is set B. This is set B. This is set B. Now set B only is now this part. Now this is our set B only. So this is set B only. So this is on set B only. So the whole of this is set B. Now this part only is set B only. So this is B only. However, this is B. So when you're dealing with set theory, it is very important that you appreciate that once somebody mentions set A, it is very different from set A only. So this part is within the universal set, as you can see. It's within the universal set but outside the union of these two sets. So this part here, within the universal set but outside the union, is A union B complement, which we can as well write as A complement intersection B complement. Now, having looked at that, we need to note that when dealing with set theory, it is important to learn and appreciate the different regions associated with the Venn diagram. For instance, when I talk about set A complement, it is a set of all elements within the universal set but outside set A. The other key point that we need to note, set A only has elements in set A but not in any other set. We must appreciate that set A only is not the same as set A. See the figure below. So we have our two sets. Now, this part here, this shaded part, is what we call set A. This is set A. Now compare this with so let us compare these two. This is set A. The whole of this is set A. Now when I come to this part here is set A only. You can see the difference, that set A is different from set A only. Now this is set A. Now this is set A only. The moment you appreciate that, then there is no way you can fail a number as far as set theory is concerned. That the whole of this part is set A. Now this is set A only, the one we write as A intersection B complement. Elements that belong to A but not B, which is this. This is set A. This is set A only. So example 1. We have the universal set. Now this is the symbol for the universal set. Our universal set has these elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our set A has elements 2, 3, 4, 5, 8. We have set B with those elements 1, 3, 5, 7, 8, 9. I want to find elements of A intersection B. A union B, A intersection B complement, A complement intersection B, A complement intersection B complement, A complement B complement, A union B complement, A complement union B, A complement union B complement. We can able handle this question using a Venn diagram. So that is our first set, second set, universal set. Now the universal set is this rectangle, so everything under this, inside this rectangle, is the universal set. So you have set A, set B. So when you check the information that we have here, some elements are in A at the same time in B. Some elements are in A at the same time in B. So those elements that are in A at the same time in B, the elements that are in A at the same time in B, we shall include them in this region of intersection. And you can ably observe that here we have a 3, we have 5, we have 8. So these elements we shall include them here. So that is 3, 5 and 8. Now which elements shall we include in this region? I'll go back to set A. I've already included 3, 5 and 8. They're already here. So the remaining elements are 2 and 4. So we shall include them there. 2 and then 4. We do the same thing for set B. I already have 3, 5, 8. So 3, 5, 8. Which elements are remaining? 1, 7 and 9. Now when you check all these elements, you come and also cross check with this. You realize that the universal set still has more elements that have not been included. So there are elements that are in the universal set but are not in the union. So when you observe critically, we have 1, we have 1, we have 2, we have 2, we have 3, we have 3, we have 4, we have 4, we have 5, we have 5 here. There is no 6 here, so meaning that the 6 will be included there, and also the 10. So these elements 6 and 10 are within the universal set but outside the union. So we now proceed. A intersection B, where do we have the elements here that belong to the two sets 3, 5 and 8. Now the second part, A union B, these elements here, we shall just list all these in order. This is our A union B. So we list all those elements. Now we have A intersection B complement, elements that belong to set A only. Elements that belong to set A only. And this is this part here. Elements that are in A but not in B. It's this part, which is 2 and 4. If I have issues identifying this, I can use the idea of shading. I just get my pencil, I come and shade set A. The whole of set A, I shade it. Then I come and shade outside set B. B complement outside set B. So I shade the whole region outside set B with my pencil. So since I'm dealing with intersection, I will take elements that are in the region that is shaded twice, and you realize that it will be this part that has elements 2 and 4. So those are the elements in set A only. Elements in set A but not B. Now we have this part, elements that are not in A but in B. We can use the same idea of shading. I will shade outside set A because it is A complement. After I've shaded that, then I will shade set B, and the region that is shaded twice is this, which is the same as B only. So we shall include those elements 1, 7 and 9, elements that are in set B only, elements in set B but not set A. I can repeat that if you want this and maybe you have issues with interpretation, what are you supposed to do? You just come and shade outside set A with your pencil. Just shade outside set A on your Venn diagram, shade outside set A. Then in the same way, shade set B with a different shading. Now that region that you find that has been shaded more than once is what will satisfy the question, and that whole region has elements 1, 7 and now elements here not in set A, not in set B. We say that this one can as well be taken as A union B in brackets complement, which is 6 and 10. So this is what I'm talking about. A complement intersection B complement is the same as A union B complement. Elements that are outside the union, this is the union, A union B. So outside the union we shall have 6 and 10. Now A complement, elements within this universal set but are not in set A. Now if this is set A, which elements are outside set A? This is A. So which elements outside set A? We have this 1, 6, 7, 9, 10. B complement, we shall take elements, this is now B, within the universal set but outside B, which is 2, 4, 6, 10. A union B complement, elements that are either in set A or outside set B, or outside set B. So elements that are in either set A, so I'll come and take set A, the elements are here, 2, 3, 4, 5, 8. Those are the elements of A. Now union outside B, B complement, that means outside B. So if this is B, now outside B, so we shall take 6 and 10. So if I want to handle this, I'll first take set A. Actually, you can use your shading, use your pencil, you shade set A. You shade the whole of set A. Shade the whole of set A with your pencil. You shade this part, that is set A. Now, go ahead and shade outside set B. Go to your Venn diagram, outside set B. Now this is set B. Now outside set B, I will take this part, the whole of this part, outside set B. So since I'm interested in the union, I'm going to take the whole region that is shaded, and that will give us these elements. Now the next part, we are going to use the same concept. Outside A, now come to your Venn diagram that you have sketched. Now outside set A, you shade outside set A, the region outside set A. With your pencil you can shade that outside set A, the whole of it. After you've shaded that, you come and shade set B. Shade set B. Now since we are dealing with the union, we shall take the entire shaded region. You realize that the only elements we are leaving out are these ones here. These are the only elements that will remain out. Let me repeat that. A complement union B. First shade outside set A, the whole region outside set A. You can shade that one with your pencil, the whole region outside set A, the whole region outside set A. You shade the whole of it. Then you come and shade set B. This is shade set B. You shade it. Now take the entire region that is shaded, since we are dealing with the union. If I'm dealing with intersection, I will take the region that is shaded more than once. Assuming this symbol was intersection, this one here, what would I do? I would shade outside set A, I would shade set B. Then the region that is shaded twice would be the region of my interest. But since I'm dealing with the union, I'll first shade outside A, then I'll shade set B. Then I consider the whole region that is shaded. So for union, you take the entire region that is shaded. For intersection, you take the region that is shaded twice. So we shall end up with elements 1, 7, 9, 3, 5, 8, then 6 and 10. So A complement union B complement. We can as well do that. Shade outside set A. So this is set A, shade outside set A. So you take the whole region that is outside set A, you shade it. This is your set A. Now shade, start with your pencil, shade this part, 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 outside set A. Now do the same thing, shade outside set B. So you come here with your pencil, outside set B, outside set B, the whole of this region outside set B. You shade it, and since we are dealing with the union, we shall take the entire region that is shaded, and you realize that this will be the same as A intersection B complement. That takes us to example 2. Still using the same knowledge. Given the sets P, all factors of 90, set Q, all factors of 60. Find the number of P intersection Q, P complement intersection Q, P union Q complement. So before we do anything, before we handle this question, the most important part, just list the factors of 9. Do some side work in your book. List the elements of P. and the elements of P are the factors of 90. So do side work, and this is the factors of 90 to present set P. Do side work to list the factors of 60, and that will represent set Q. Let us all do that so that we compare. Take 1 minute and list the elements of set P and also list the elements of set Q. Where the elements of set Q are all factors of 6, where the elements of set P are all factors of 90. If we cannot list these elements, then it becomes very hard for us to handle the question. All factors of 90, it means that we are taking all those numbers that can divide 90 and we don't get any remainder. Like for instance, I can get 90 and divide it by 2, so meaning that 2 is a factor of 90. I can get 90 and I divide it by 1, meaning that 1 is a factor of 90. So we list all those numbers that will satisfy that condition. Please list those numbers in your book and then compare. So the elements of P will be 1, 2, 3, 4, 5, 1, 2, 3, 5, 6, 9, 15, 18, 30, 45, 90. Can you ask yourself why we've not included 4 in this set P? Yes, I've not included 4 because 4 is not a factor of 90. Once I get 90 divided by 4, it will not give me an exact value. It will give me a value together with a remainder. Elements of Q, the same thing. We take all those elements that can divide 60 without giving us any remainder. You may ask yourself, why haven't we included 8 in this? We've not included 8 because when you get 60 divided by 8, you'll get a decimal. We shall not get an exact value. So P intersection Q, we just check through this, which elements are in this set P at the same time in set Q. You list them here. You can see there is 1 cuts across, there is 2, there is 3, there is a 5, there is a 6, there is a 15. You can see the 15. There is also a 30. So those elements that cut across. Then the number, how many are they? Those are 7 elements. Now we come to this. How many elements are not in set P but are in set Q? That is set Q only. So come to set Q and take those elements that are in set Q but not in set P. In other words, take this set Q and remove the elements of the intersection. So out of this set Q, you remove these elements here of intersection. We shall come up with set P complement intersection Q. And how many are those? Those are 5 elements. The next part, P union Q. We just list these elements without repeating. Don't repeat an element because it's the other side. You don't have to repeat it. Once you repeat the element, now like there is a 3, there is a 3, you don't have to write it 2 times. Once you write it 2 times, then you'll be distorting the question. So elements that are in either set P or set Q. And how many are they? You can count. Those are 16 elements. Example 3. We have that information. You can analyze it. Sets A and B are such that the number in the inverso, this is our inverso, is 30. The number of A is 18. Number of B is 14. A union B complement. Outside the union, we have 5. But within the inverso, what are we interested in? So we have that question. We begin by sketching. Now this is the inverso set. We start by doing the inverso. This is the inverso set. This rectangle is the inverso set. We put in the information. That is our set A. It is our set B. Our inverso is 30. A is 18. B is 14. This information here, number of A. Once I say number of A, I mean number of elements in set A. The whole of this You cannot bring it here. This is not A. This part I'm pointing at is not A. The A we are talking about is this. This entire circle is the A. So this is the A. The entire circle here is the A. So this is set A. So the number of elements in this set is 18. Now the number of elements in this set, the order of this set is 14. So we can take the intersection to be x. So since this one is x and we have the order of this as 18, it is an indicator that this part here, the A only, will be the 18, which is this. This is the 18. If the order of this is 18 and this part is x, then it means that this part will be 18 minus x. In the same way, if this part is 14, this is 14, and this part is x, then it means that this part will be 14 minus x. Now we have more information. You see this outside the union but within the universal. This is the union. Now outside the union but within the universal, we have 5. Now the remaining work is to add all this information and equate it to the universal set, which is 30. That will help us to get the value of x. Proceed. So we add this 18 minus x plus 14 minus x plus 5 should give us 30, and we shall get the value of x as 7. Now we got back to the question. A intersection B is the x, which is 7. Now A union B. A union B is this part. This, and that. This is the union of these two sets. So I'm going to take this part. Now this part is 11. How am I getting the 11? I'll get 18 minus the x, but the x you've got here is 7, so 18 minus 7 gives us 11. This part is 7. This part here is 14 minus 7. 14 minus 7, which gives us 7. When we add that, end up with 25. Now this part we earlier talked about, this is A only. Elements that are in set A but not set B. Number of elements in A but not B, which is this 18 minus 7, which is 11. Now also have this number of A union B complement. I said if you find issues with this, you don't have to cram this. If you find issues with this, just go to your Venn diagram, shade set A. This is your set A. Shade the order of set A. This part, shade the order of set A. Now union outside set B, so you now shade B complement, that is outside set B. So you shade that whole region. So you realize that the elements you're ending up with are 11, 7, and then 5. That will give us the 23. If you're dealing with union, you require the entire region that is shaded. If you're dealing with intersection, you require the region that is shaded twice. So if I want A union B complement, I'll come and shade A, the order of A. Then I'll come and shade outside set B. So outside set B, I'll shade that region outside set B. And I'll take the entire region that is shaded, which will be 11 plus 7 plus 5. That gives us 23. Example 4. We can analyze that information, try to interpret that. We have sets A and B. The number in the universal is 40. The number of A is 25. Now outside A but within B, this is B only, is 10. Number of A intersection B is equal to number of A union B complement. That elements that belong to A and B are the same as the elements that do not belong to the union of the two sets. We can put that in a Venn diagram. So we draw our universal. That is our first set. Our second set. The universal is 40. number of A is 25. I said when you say A, it doesn't mean this part, it means the whole of this part. This is the A. So this is set A. Once I say set A only, then I'm referring to this. So this is A only. This is A only. And this is A. So the whole of this part is A. A only is this. But we've been given A. So this is number of A, which is 25. Number of B has not been given to us. So we have the intersection, we are calling it X. So if this is X and the whole of this is 25, then it means that this part here is 25 minus X. The whole of this is 25, but this part is X. So this part will be 25 minus X. We have this other information, elements that belong to B only 10. So we shall bring the 10 here. And we've been told that the elements that belong here are equal to the elements that are outside here. So all the information has been incorporated in. So the next step is to add all this. So you take 25 minus X plus 10 plus X is equal to 40. And that will be in position to give us the value of X. So 25 minus X, which is this, plus X, which is here, plus 10. Now plus the X should give us 40. And on solving this, we get the value of X as 5. What is the question? A intersection B is 5. A union B. This is 25. A union B is this part. This, and that. You can just shade this. Shade set A, then also shade set B. Now take the whole region that is shaded. A union B. If I don't know this region, I will shade A. Then also shade B. And since I'm dealing with union, I will take the entire region that is shaded. So this is 25 minus 5, which is 20. Now this is 5, this is 10, to give us 35. Example 5, you can read through that. In a class of 29 boys, 22 like rice, 18 like matoke. All the boys like at least one of the foods. Find how many liked both. I summarize the question. I have the inverse set here. I have the two sets there drawn. The inverse is 29. The rice is the whole of this, as I've been mentioning. This is rice. This is matoke. All the boys like at least one of the food, so it means that outside here. So in the center here we shall have X. We shall have 22 minus X, 18 minus X. Why? The whole of this part here is 22, but now this part alone is X, so this part will be 22 minus X. If the whole of this is 18, this is 18, but this is X, that means this part is 18 minus X. But we have this information, all the boys like at least one of the foods. What does that one mean? It means that this statement here, all the boys like at least one of the foods. It means that in this region there is 0. We can include the 0 or we may not include it. You can put a 0 here or we may not include it. So meaning that if this is 0, then 22 minus X, which is this, plus X, plus 18 minus X, now plus the 0 that is outside here, should give us 29. We shall get the value of X as 11. So we got question 6. You can read through that and summarize the question. In a class of 20 girls, 5 play golf but not netball. So that means 5 play golf only. 9 play netball but not golf. That means 9 play netball but not golf. So 9 play netball only, while 3 play neither game. So 3 do not play any of the games. So how many play both games? How many play either game? Only one game. Take your universal, which is there. Take your first set, the second set. So our universal is 20, which is here. So number of golf. So we have also number of netball there. This is the set for netball. Number of netball, number of golf. So some play both, so we shall call it X. 5 play golf but not netball. So we say that 5 play golf but not netball. 9 play netball but not golf. So how do we incorporate that? So 5 play golf but not netball. So that means that 5 play golf only. So this part is 5. Golf only. These are 5. They play golf only. 9 play netball but not golf. That means 9 play netball only. Because of that, we shall put the 9 there. 3 play neither game. So we shall put it outside here. So what is remaining is just simple algebra. Add this. Can you do that? Do that in your book. Get 5, add x, add 9, add 3, and equate to 20. We shall be in position to get the value of x. So add that. Get 5, add x, add 9, add 3, equal to now the inverse. Because the inverse is this, whatever is here should add to 20. So we shall take 5 plus x plus 9 plus 12 equal to 20. And that means we shall get the value of x at 3. So how many play both games? 3. How many play either? That means the union. We shall take 5 plus 3 plus 9, which gives us 17. Only one game, that means golf only and netball only, which is 5 and 9, giving us 14. So after having discussed the first part of 2 set cases, we shall now proceed and extend that knowledge to 3 set cases, where the information given concerns 3 sets may be A, B, and C. We now take a short break. Let us extend the concept of 2 set cases to 3 set problems. As far as 3 sets are concerned, the knowledge that we use is not different from the knowledge that we discussed under 2 set cases. But the most important part here is you appreciating the regions associated with the set theory. So we are going to consider 3 sets, A, B, and C, as shown in the Venn diagram below. So we have our first set, second set there, third set, universal. We have that as A, that is B, that is C. Now I want to take A intersection B intersection C. Now the region that cuts across the 3 sets is actually this. Now this is the A intersection B intersection C. The region that cuts across, realize that this region is part of C, the same region is part of B, the same region is part of set A. So that is our A intersection B intersection C. We can proceed and look at A intersection B. Still consider 3 sets. That is the first set, second set, third set, our universal, set A, set B, set C. Now what A intersection B? Now assuming C is not there, you can remove set C. If I remove set C from this Venn diagram and I want to take elements that belong to A and B, realize that the part that we shall shade is this one here, which is A intersection B. So the A intersection B goes up to this point. So meaning that A intersection B intersection C is part of A intersection B. A intersection B intersection C, this part is part of A intersection B. In the same way, A intersection B intersection C is part of B intersection C. Similarly, A intersection B intersection C is part of A intersection C. It's part of this. So this part is actually part of A intersection C. We can look at A intersection B only. Different from A intersection B. A intersection B is different from A intersection B only. So A intersection B intersection C complement can also be referred to as A intersection B only. So still consider 3 sets which you can sketch A, B, C. So want A intersection B only elements that belong to A and B but not C. So which means that C is out. So elements that are in A at the same time in B but are not in C. We shall have that particular part. So this is our A intersection B only. This is our A intersection B. Hope you can get the difference. A intersection B, A intersection B, intersection C complement. That's where the difference is. A intersection B, A intersection B only. We can look at set A. That is set A, set B, set C, our universal A, B, C. Now set A. Set A, we take the entire region that has set A. So we shall shade that. So that is our set A, the entire region that represents set A. How about if we take set A only? As I said at the start, set A is different from set A only. So I'm going to sketch 3 sets there. Universal, set A, set B, set C. So set A only, elements that belong to A, not in B, not in C. They are not in B, they are not in C, but they are in set A. This is our set A only. So I want you to appreciate the fact that set A is different from set A only. So once I say set A, I'm referring to this part. Once I say set A only, I'm actually referring to this part. We must note that difference. The moment we appreciate and learn that difference, then we shall have no issues as far as set theory is concerned. So this is set A. Once I say set A, I will shade the entire region. Set A only, I will restrict myself to the region that belongs to set A, not B, not C. So can we take the first example to digest the information that we have discussed above? We have that question. The information is clear. You have the inverse as 100, number of A 46, number of B 40, number of C 49, A intersection B 14, A intersection C 17, B intersection C 15, outside A intersection outside B intersection outside C, or A complement this part, intersection B complement, intersection C complement, that is 6. Outside A at the same time, outside B at the same time, outside C. So want to find A intersection B intersection C, A union B union C, A complement intersection B intersection C, A intersection B complement intersection C, A intersection B intersection C complement. Transfer the information onto a Venn diagram. So we put the first diagram there, the second one, the third one. So our universal is 100. We are getting the information from here, from the question. The universal is 100, which I have included there. So number of A is 46. So the A is actually this. The whole of this part is the 46. So once you write the 46 in this part here, then you will have misfired, because this region is A only, but we are told number of A. So the whole of this is 46. Now number of B, this part, which is 40. So you don't put 40 here. The 40 represents the whole circle. Now number of C 49, which is this part. Not here. Once you put it here, it will not be right, because this part is C only, but the question says number of C, which is actually this. So we are taking this intersection to be X. We have more information that A intersection B is 40 now. Earlier on we said that A intersection B means the region from this point, the whole of this region is 14. But because this one is 14 and already have X here, it means that this part will be 14 minus X. Now we have A intersection C. The order of this region is 17, and because this one is 17, it means that this part will be 17 minus x. Now the order of this part is 15 as given in the question. B intersection C is 15, but this part is x, so this will be 15 minus x. You realize that some components of our Venn diagram are lacking information. We don't have what is here, we don't have what is here, we don't have what is here. So it is important that we get to know what is in this region here, and that's what we are going to look at. So number of A only, this part, how shall we get this? You realize that once I get what is here plus this plus this plus this, I should be getting 46. If I get this, add this, add this, add this, it would now give me the set A, which is 46. So meaning that getting what is in this part A only will be 46 minus the sum of these, and that is the idea we shall use. 46 minus the sum of these. So 46 minus the sum of these. So we shall take 46 minus 14 minus x plus 17 minus x. Now you realize that this and this will cancel. So this and this will cancel. And then 14 plus 17 will give us 31. So this and this cancel. So we have 31 minus x. Now once we open the brackets here, we shall have minus 31. Now a minus and a minus here, minus minus will give us a positive, and that gives us this region as 15 plus x, which we take here and write there. Now using the same approach, we can get number of B only. Can we try out that? Number of B only. Now we'll try out that. You'll get 40 minus 14 minus x plus 15 minus x. 40 minus 14 minus x plus 15 minus x. Now this and this will cancel, meaning that we shall have 14 plus 15 giving you 29 minus x. So 40 minus 29 minus x. Now similarly, this negative and this will make the x a positive. So 40 minus 29 plus x, that gives us 11 plus x. Now you take it there. We proceed, use the same approach and get number of C only, which will be 49 minus 17 minus x plus 15 minus x. So the computation there, the x and the x will cancel, minus x and that, we shall have 32 minus x. Once you open the brackets, we shall have 17 plus x. So we shall write the 17 plus x there. Now we continue. We have the information. Now where is this 6 coming from? Earlier we have been told that number of A complement intersection B intersection C complement elements that are not in A, not in B, not in C. Those were 6. So we include it here. So at this point, we are now going to add everything here. Add everything here, including this 6, and we equate to 100. Now, I would have taken 15 plus x plus 14 minus x plus this plus this plus this plus this, now plus what? Plus 6. But you realize that as a way of saving time, I may not have to add the order of this. You realize that this, you observe this one critically. Try to see this. If you added these values here, what would you get? You can check. You realize that what I'm pointing at, this region here, is actually set A. And we know that the number of A is actually what? 46. So instead of adding this, and that, I don't have to do that. I know that the order of this one is what? 46. That's why I've written 46. So this sum here is 46. Then I add this 11 plus x, add 15 minus x, add 17 plus x, and then add the 6 to give me 100. Now at this level, the remaining work is just algebra to give us the value of x as 5. So meaning that those who belong to all the three sets A, B, and C are actually 5. Back to the question now. A intersection B intersection C, we've got it as 5. Now A union B union C, so the union here, realize that the whole of this set is 100, but outside here we have 6, so meaning that this union should be 100 minus 6. If you don't want to do that, you can substitute the value of x as 5 here. You add 5 here, put 5, put 5, put 5, put 5, put 5, put 5. Now add. But that will be a wastage of time. Instead of going through that, I will simply get 100 minus 6 to give me 94. Now B and C only. So we look at B and C only, which is 15 minus x. But what is x? 5. So 15 minus 5, giving us 10. Now this is A intersection B complement intersection C, the same as A and C only. So we got the Venn diagram A and C only, which is this part actually. 17 minus 5, giving us 12. A and B only, A and B only, which is 40 minus 5, giving us 9. We now proceed to the next question, and all the working will just actually be the same. So question 2. In a class of 53 students, 30 study art, 20 study French, 15 study computer, 6 study both art and French, 4 study art and computer, 5 study French and computer. Each student studies at least one of the 3 subjects. We can summarize the information there that has been given. We make a summary. Now this summary is derived from what is here. So we've been told that each student studies at least one of the 3 subjects. So meaning that all the students are within the union. We don't have a student outside the union. That's why we are putting a 0 here. So we can now draw a Venn diagram. So we have our universal set, our first set, second set, third set. We label them universal 53, A 30, F 20, C 15. So outside, I mentioned that the fact that we've been told that all the students belong to at least, it means that outside the union but within the universal we have 0. So everybody belongs to these 3 sets. So also have more information that those that belong to all the 3 sets are Y. So we shall put Y here. Now in the question we have that those that belong to A and F were 6. Now the 6 is this part here, but the fact that this one is Y, it means that we shall remain with 6 minus Y. In the same way, the whole of this part, when you check the question, the whole of this part is 5, but this is Y, so this will be 5 minus Y. Use the same working here. The whole of this part is 4, but this is Y, that gives us 4 minus Y. Now I can work out number of A only. I can either work it out here, or I can even do it directly here. If I want A only, I will get 30, like we did in the previous example. I will get 30 minus 4 minus Y plus 6 minus Y, but everything in brackets. So 30 minus, so I will take 30 minus, open brackets, 6 minus Y plus 4 minus Y, and close brackets. Then the same thing here, we shall get 20 minus the sum of these. The same working here, 15 minus the sum of these. That's what we have to do. If you want, you can work out this one independently. You can put it here. Number of A only, you simplify that. Number of F only, you simplify it there. Number of C only, you simplify it. There will be no problem with that. So we now proceed to add everything here and equate 53. If you don't want to put these values here, the way it is here, you can simplify it here. You can actually see this and this will cancel. So meaning that you have your 10 minus y, which will give us 20 plus y. So if a student has 20 plus y here, that is still okay. If a student has, you can see this is 11. So 20 minus 11, 9 plus y. So if you have 9 plus y here, it is still okay. I can see this is 9. So 15 minus 9, 6 plus y. So this part is 6 plus y. So if you have 6 plus y here, it is still okay. So we shall proceed and sum up. As I said in the previous question, the whole of this part here, look at the part I'm pointing at. When you sum up all these, what do you end up with? Once you sum up this, you end up with 30. So we shall not waste time. So this is 30. That's why I've written 30 here. But if you want, you can say this plus this plus this plus this, but we still give us 30. So the whole of this is 30. So that is 30. Now add this. Now add 5 minus y. Add this part here. Should give us 53. So once we simplify that, we shall get the value of y as 3. Simplifying here should not be a problem. You can start by simplifying what is in the brackets, simplify it and proceed to open the brackets. We shall end up with y as 3. So having got y as 3, we now go back to the question. How many like all the 3 subjects? It is y. That is 3. At least 2 subjects. At least 2, it means 2 subjects and above. At least 2. Come with at least 2 pens. It means you can have 2 pens, you can have 3 pens and more. So number of at least 2 subjects means 2 subjects and above. So we shall take this part, this part, this part and that. 2 subjects and then 3. So we have 4 minus 3, 5 minus 3, 6 minus 3, which is here, and then we shall have the 3. And that gives us an answer of 9. Now find the probability that a student chosen at random studies only one subject. Only one subject. Now which region is that? I have this, I have this, I have that. We just need to simplify that. Only one subject. You have this, you have this, you have that. Can we substitute there? So 23, where is the 23 coming from? It's coming from this part here. Only one subject. So this is we have to substitute here. Substitute the value of y here. This is 10, 20 plus 3 giving us 23. Come to this part. This is 9. So 15 minus 9, 6 plus 3. So we have only one subject. We are taking this. So once you simplify this, remember the value of y, you just substitute the value of y here. So once we substitute here and substitute the value of y here, we can verify that. Substitute your value of y. So substitute y here, substitute y here, substitute y here. Then divide by the number in the inverso, which is 53. So once we take that, we shall end up with 44 out of 53. Now French only. Find the probability that the student chosen at random studies French only. So we shall take 12, which is actually here. We divide by the universal, which is 53. You don't have to write a decimal. As long as it is a fraction in the simplest form, we can always take it at that. French but not computer. So this is French but outside computer. So this is French. You just check French but not within computer. So French but outside computer. So this is French, then outside computer. Those that are in French but outside computer. So we shall have this and that. Just substitute the value of y. Check that. Substitute 3 here and also substitute 3 here. So we shall sum up this and that. French but not computer. So we have this and that. So it gives us 15 out of 50. We can now take example number 4. We can summarize: in a class of 100 students, 15 take art only, 12 take French only, and 8 take computer only. 10 take both art and French, 40 take art and computer, 20 take French and computer, and 65 take computer. Represent the information on a Venn diagram. Find the number of students who take all the 3 subjects: art, then French. Find the probability that a student chosen at random takes neither subject. So number in the universal is 100. Number of A only is 15. Number of F only is 12. Number of C only is 8. Number of art and French is 10. Number of art and computer is 40. French and computer So we summarize and draw a Venn diagram for it. We start with the universal. We have the first set, the second set, and then the third set. So our universal is 100. We have number of A, number of F, number of C, which we are given as 65. More information: those that take all the 3, we are calling it Y. So why are we taking 10 minus Y? We are told that art and French. So this is art, this is French. This is art, this is French. Art, French. So we are going to take this as 10. So the whole of this part is 10. So if the whole of this part is 10, then it means that this part will be 10 minus Y. Now the whole of this part here, art and computer, is 40. This is 40, meaning that this part will be 40 minus Y. We are also told that number of French intersection computer, 20 take French and computer, which is here. So 20 French and computer, this part here is 20, meaning that this part will be 20 minus Y. We have more information that 15 take art only, so we shall put the 15 there. That is for art only. Now 8 take computer only, shall put it there. So we have the 8 that take computer only, we have the 12 that take French only. So we have almost everything. We also have more information that some students do not take any of these subjects. So we have some students that are outside here. We can make it another unknown X. So you realize that if you add all this, if we add all this, if we add all this, we should be coming to 100. However, you realize that we have two unknowns. We have x, we have y. So if I add this and equate to 100, the equation I come up with will have x and y, which will not be easy for us to solve, since the unknowns will be 2 in one equation. So if you add this, you come up with an equation that has x and y. You can check that. Add all this information here and equate it to 100. The equation you come up with will have x and y. However, you realize that we have some more information here. So this time I'm going to use number of computer, which is this. So we are going to add this. We can formulate an equation from computer, because if we add and equate the inverse, this x and y will be in the equation, which will be very hard for us to solve. So I can take a shortcut and I first add this. So once we take that, so we shall use the equation for computer. So once we take the equation for computer, we shall add this. So this is 40 plus 20, that gives us 60, 68. Actually, this equation, you can come up with this equation, get this, write it somewhere. 40 minus y plus 20 minus y plus 8 is equal to 65. We shall get the value of y at 3. So number of at, this is the circle of what you just now add. 15, this is 10 minus 3, this is 3, this is 40 minus 3. So 15 is here, 10 minus 3, this is 3, this is 40 minus 3. So that gives us 62. Number of French, the same thing. Take 12, which is here, 20 minus 3, which is here, then 3, and then 10 minus 3. And that gives us 39. Neither subjects, these ones who are outside here, it means that we shall take 100 minus the whole of this, minus the union. That's what we are going to take. So get 100, which is this, minus the union here. However, this part is already 65, this is 12, this is 7, this is 15, and we end up with 1. So the required probability will be 1 out of 100. This is the inverse set. This now takes us to example 5. In the Venn diagram below, sets P and Q aside that number of P union Q is 16, number of P complement is 7, number of Q complement is 6. So the information was given, you have P, you have Q. All that was given. So find the values of A, B, and C, hence obtain the inverse set. So we follow this. We are told that P union Q is 16. Where is the union? A plus 7 plus B should give us 16, which is here. A plus 7 plus B should give us 16. So A plus 7 plus B should give us 16. Now that gives us the first equation, A plus B is equal to 16 minus 7, which is 9. Now outside Q, number of Q complement outside Q, this is set Q. Now outside Q, what do you have? You have A and C. Those are equal to 6. More information, outside the P is 7. If this is P, now outside P is 7. Outside P is 7, which is B plus C equal to 7. Now once we get to this level, we just need to solve these equations simultaneously. You realize that we have 3 unknowns, A, B, and C. When I look at the third equation has B and C, so it is lacking A. The third equation has B and C, so it is lacking A. What am I going to do? I'm going to combine the first equation and the second equation with the purpose of eliminating A. Why am I eliminating A? Because the third equation does not have A. I repeat, the third equation has B and C, so it is lacking A. What am I going to do? If the third equation is lacking A, then I'm going to combine 1 and 2 with the purpose of also eliminating A. So that's what I'm doing. So I want to eliminate A. You realize that this is a positive, this is a positive, so I will subtract to eliminate A. So A minus A minus A, 0. B minus C will now be equal to 9 minus 6, which gives us 3. So do you realize that now this equation 4 and this equation 3 are in the same dimensions? B minus C equal to 3, B plus C equal to 7. You now solve them simultaneously. So we now solve those equations simultaneously, and my target here is to eliminate C. This is a positive, this is a negative. Different signs, add, because I want to eliminate C. So B plus B, 2B. 7 plus 3, 10. We end up with the value of B as 5. Now once you get B as 5, substitute it in the first equation. So we shall have A as 4. Now substitute in the second equation, shall get the value of C as 2. That is the first part of the question. Find the values of A, B, and C. Hence, obtain the number in the universal set. We just add A plus 7 plus B plus C. And then we shall end up with our universal set as 18. Now that takes us to the next question. Example 6. Information was given to us that we study, so our work is just to study what has been given to us. So everything was given to us, we just need to study and then we apply. So we study and then apply. Find the values of A, B, and C. Find the number in the universal set. So we are going to derive the equations. You realize that here number of P, once I add all this, I should be getting 24. So I will say 6 plus B plus 3 plus A should be 24. So I come up with this equation. Now similarly, formulate another equation from Q. Add all this and equate it to 26. So we shall have B plus 4 plus 3 plus C equal to 26. Not 36 but 26. This is a 26 because number of Q is 26. So this value here is not a 36, it is actually 26. So you check that. So B plus 4 plus 3 plus C should be equal to 26, not 36. So you realize that once you subtract 26, please adjust this to 26. So 26 minus 7, because this is 7, will give us 19. Apply the same working on R. So we add A plus 3 plus C plus 7 equals 28. So end up with A plus C equal to 14. Now once you get to this level, you apply the same knowledge like in the previous question that we've just done. Apply the same knowledge like in the previous question. So the third equation has A and C. What is it lacking? It is lacking B. So this equation lacks B. So I'm going to combine 1 and 2 with the purpose of eliminating B. So I'm going to eliminate B. Now since this one is a positive, check here. Positive, positive. Same sign, subtract. So A minus C, B minus B is 0. 15 minus 19, negative 4. So we now come up with this equation. Realize that this equation 4 and equation 3 all have A and C. A, C, A, C. We now solve them simultaneously. A plus C is equal to 14, A minus C equal to negative 4. So we just solve the equation simultaneously. By adding, we add to eliminate C. So our 2A will be 10 and our A will be 5. Substitute in equation 4, our C will be 9. Substitute A in equation, substitute A equal to 5, so we shall have B plus C equal to 19. So we shall end up with the value of B as 10. So number in the universal, we sum up everything and we shall come up with a universal set